Hey folks, so in previous tutorial we learned about thread lifecycle and we understood how we can create thread in multiple ways. This video is to demonstrate that how executors library work. Basically, if you work with Java's native threads and don't use executors, then you would have to have a burden of managing the creation of threads and other things. So the job of managing the threads and organizing those is taken care of by executors. So that's the reason we use executors, and this is a well-defined library and it is used in very large scale applications. So in this section we will discuss how we can create multiple executor services instances for different types basically. So basically there are three types that are available. One is cached thread pool, second is fixed size thread pool, and third is single thread executor or single thread. Well, we can't call it pool, but let's say single thread pool. So basically, we have executors class. So I can even show you that. Let's do that. So we have this executors class. This contains a lot of utility methods and the methods that create these pools for you, right? And when we create these pools, these are an instance of executor service, right? So that's all that we will learn in this section, and I will give you a very small example of using Threadpool Executor as well. So for this one, that's how we declare it and use it, right? Executors dot new cache thread pool. This is a method that we call which creates a cache thread pool. So by cached, here we mean that there is no limit, or actually there is a limit, but that's a very big number. So you have a pool where as soon as it receives a task, it creates a thread and runs it, and that keeps on going, right? So let me tell you that number. This is the max pool size for cache thread pool, right? That's a big enough number. You probably won't be having this number of tasks at the very same time. So one good advantage of cache thread pool is that it gives you the flexibility that you could execute n number of tasks that are supported by your OS, your machine's hardware basically. Okay, so here let me show you what we have got in task. So task implements runnable, and I'm just printing abracadabra for 10 times. Okay, and I have added a sleep of, well, let's reduce it to execute it faster, of 500 ms, and we have this execute method. So this execute method doesn't belong to execute service, rather it belongs to executor interface here, right? And it takes runnable as a parameter. So executor service is like an interface that extends executor and adds more such utility methods. So you could see shutdown is terminated, is shut down, await termination. So we will see the uses of shutdown in this particular use case even. So so we don't need this, so we can get rid of this as well. So that's how we declare a cache thread pool. And then if I have to add, say, 3 tasks, so why am I calling threads a task? Because in executors we consider something, well, a runnables instance or callable. I will talk about callable later, or callables instance as a task, and that is executed over the time. Well, we don't know when it will be executed, so that execution happens uh, in the executor service. Executor service creates its own thread and then calls one method of that task. So that seems very simple. You just need to create the new cache thread pool. You need to have executor service as a reference variable, and then you could add as many tasks as you want, and then once you are done, you could actually shut it down. So let's run it. So it goes when running. So if you don't shut down, we don't know like whether our pool is going to be down or not. So this could lead to memory leakage. So whenever you create an executor service, you actually should shut down. That's the most commonly used one. And as you can see, the only difference from the previous example is this. Here, I am calling the other method, that is new fixed thread pool, and I am passing the pool size. So I have passed the pool size too. So in the previous example, you can see that as many tasks I created, as many threads got created. Thread 1, 2, 3, right? Here, in this, I am creating a pool of size 2 only. So at a time, only 2 threads would be there. So let's run it. You see, it's only 2 threads at max. 1 2 1 2 1 2. So this is the basic difference between a cached and a fixed thread pool size. So this is a commonly used one, and this gives you one advantage, that in the situations where you are getting a lot of tasks to perform, you're performing, or you're executing only the tasks that you can, or your system is able to do that. So you could limit that at a time, right? Very easy one. That's that's new single thread executor. So like the name suggests, there you will always be having one thread at max, and rest of the things are same. That's why. Meanwhile, I would like to talk about the README file. Uh, so this README file have summarized a quick details of how things work, and how how those are organized in the library, and some basic details. For example, here I have got executor, executor service, scheduled executor service. These are the interfaces of the executors library. We talked about this and this one, right? This one we could talk about later. But yeah, good to know thing. Okay, so it has executed, and you could see it's all the time thread one. Yep, cool. I would like to show you one more example of using a Threadpool executor. So Threadpool executor is the class that is extending abstract executor service, which actually implements executor service. So this class have got some interesting methods basically. So let me show you few of those. So I created a cache thread pool here, and I am typecasting executor service instance to Threadpool executor. That's possible, right? Because both are in the same hierarchy of inheritance. And I can set code pool size, or I can get code pool size. I can get maximum pool size, and things like that could be done, right? So let me run this, and let me show you what these do print. So here it shows that what is the maximum pool size, right? And also, as of now, the core size is set to 2, like I set it. It is showing up showing that up. It's a size 2. What exactly core tool size means is that even if there is no task, there would be some set of threads still available. That is the core tool size. Okay, so that's it for this tutorial.